Good day, everyone. This question comes from one of our followers from Korea, and the question goes like this. Solve for the values of a and b such that it satisfies this equation, the integral of x minus t times f of t dt from 1 to x equals x cubed plus ax plus b. You can pause this video if you want to give this problem a try. And now, let's answer this question together. So, our goal is to solve for the values of a and b that satisfies this equation. Now, before we start our solution, our answer to this question must be a equals -3 and b equals 2. Now, the real question is, how do we get this result? And here's our solution. To answer this question, we need to focus on this function f of t. Now, we need to decide if this f of t is a linear, a quadratic, a cubic, or so on and so forth. But take note that the right-hand side is a cubic expression. Therefore, the expression on the left-hand side must be a quadratic expression, because a quadratic expression, when we integrate, it turns to a cubic. Therefore, f of t must be a linear function, so we can replace f of t as pt plus q. Now, the left-hand side of our equation becomes the integral of x minus t times pt plus q dt from 1 to x. Next, what we're going to do is to simplify this expression, so let's multiply x minus t to pt plus q. Now, let's distribute this x. And then, let's distribute this negative t. Now, what we're going to do here is to integrate ptx plus qx plus pt squared minus qt with respect to t, then evaluate from 1 to x. So, if we do that, we get, take note that only t is the variable here and all of the other variables is constant. So, ptx, if we integrate this, we have pxt squared over 2. If we integrate qx with respect to t, we have qxt. If we integrate pt squared, we have negative pt cubed over 3. And if we integrate negative qt, we have negative qt squared over 2. Next, we need to evaluate this. So first thing to do is to replace all t with x, minus, we need to replace all t by 1. So it looks something like this. So on the first expression, we replace all t by x. So we have px times x squared over 2 plus qx times x plus px cubed over 3 minus qx squared over 2 minus, then replace all t by 1. So we have px times 1 squared over 2 plus qx times 1 plus p times 1 cubed over 3 minus q times 1 squared over 2. Now, let's simplify first all of these expressions. Now, px times x squared over 2, this is just px cubed over 2. Then qx times x is just qx squared. And then we can simplify this also. Now, all of this 1 is just 1. So this is equivalent to just px over 2 plus qx minus p over 3 minus q over 2. Next, let's distribute this negative sign. And now, let's combine similar terms. So we have px cubed over 2 and negative px cubed over 3. If we combine this, we get px cubed over 6. Next, let's combine qx squared and negative qx squared over 2. If we combine this, we get positive qx squared over 2. Now, let's combine all terms having a variable x. So I have negative px over 2 and then negative q times x. If we do that, we get a negative of p plus 2q times x all over 2. Now, this is the result when we integrate ptx plus qx minus pt squared minus qt dt from 1 to x. Now take note that the result of this integral is also equal to x cubed plus ax plus b. So what we're going to do here is to just compare these numerical coefficients. So first, let's compare the numerical coefficient of x cubed. So we can say that p over 6 must be equal to 1. Now, solving for the value of p, let's multiply both sides by 6. So we get that the value of p must be equal to 6. Now, we found the value of p. Now, how about the value of q? Now, let's compare the coefficient of x squared. Here we have q over 2, and on this equation, we have 0. So we have q over 2 must be equal to 0. So we can say that q must be equal to 0. So now, we have p equals to 6 and q must be equal to 0. So we are now ready to find the values of a and b. Now, the value of a, comparing to this equation, the value of a must be equal to negative p plus 2q over 6. But we know the value of p and q. P is 6 and q is 0. So we can replace this p as 6 and this q as 0. This is just 6 plus 2 times 0 over 2. Or simply, this is equivalent to just negative 3. So a must be equal to negative 3. Now, how about the value of b? B is just p over 3 plus q over 2. Now we know that p is 6 and q must be 0. So b must be equal to 6 over 3 plus 0 or simply equal 2. Therefore, our answer to this question is a must be equal to 3 and b must be equal to 2. And as always, we are done.